All right, so let's look at 1.9, question 6. Okay, so once again, if we look at the, oh, you can't see the screen. Can anyone else see the screen? Okay. All right, so other people can see the screen. So we'll go ahead and go through the problem now. All right, Sherry is married and has a combined income of $63,000. She has one child with a health condition. She can claim the following deductions: $5,500 in property tax, $6,750 in mortgage interest, $1,750 in charitable contributions, and then $11,500 in qualifying medical expenses. Okay. There were no mention of any adjustments on here. Okay. So for this example, our gross income is going to be the same as our adjusted gross income because there are no adjustments to take off. Okay. So the gross income was $63,000. The adjusted gross income is the gross income minus adjustments. Okay, so that's also $63,000. Okay, so now we figure out what's the value of the itemized deductions. Okay, so we add up the deductions that we have listed. So the 5,500 plus the 6,750 plus the 1,750 plus the 11,500. Okay, that adds up to 25,500. Okay, since that is more than the standard deduction, we'll use the itemized deductions. Okay, so the taxable income is going to be the adjusted gross income, and then we subtract the deductions. Okay, so we get $37,500. Okay, so that's the taxable income. All right, now what we want to do is compute the tax. So first what we do is we set up the I like to call them buckets, or you could think of them as tax brackets. Okay. We have a 10% tax bracket. 37,500 will land in the 12%. So that's as high as we need to go. We don't need to go up to 22 in this example. Okay. And the 10% tax bracket is full. It can hold $19,750. The remainder of the taxable income will go into the 12%. Okay. So what we have is 37,500, but 19,750 has already been accounted for in the previous bracket. So if I subtract that, we get 17,750. Okay. And again, if you add these two numbers, they should add up to your taxable income. That's kind of a check that we can do. So I add them and I get $37,500, so I know that I haven't lost anything. Now we compute the tax by taking the percent of the amount of money in each of these buckets. So we're going to take 10% of 19,750, and we're going to take 12% of 17,750. Okay, so for the 10%, we get 1,975, and then for the 12% of the 17,750, we get 2,130, and so our computed tax. Okay, I add these two and get 4,105. Okay. The tax owed is the computed tax, and then we take away credits. Okay, so after we figure out the percentages, that's when we subtract away the credits. So I have $4,105, and I take away the $2,000 that we have as a child tax credit. Okay, so I get 2,105. That's how much tax they're responsible for the whole year. Okay. Sherry's W-2 says that she paid $2,520 in taxes in 2020. Okay. So what you want to do, and I think the best way to look at this and not make a mistake, is to think about what makes sense. Okay. She paid, oops. She paid $2,520. She only owed $2,105. So she paid more than she owed. And if you overpaid, you need to get your change back. Okay, so she's getting a refund back. And the refund is the difference. So I take 2520 minus 2105. And I get $415. So they're going to get a $415 refund. Okay. If the amount they paid was less than the amount that they owed, then they would have to pay more, right? Because they haven't paid enough yet. All right, any questions so far? We're not done with the whole problem yet, but that's the computing tax part, and then we'll go on to the percentages part. So the exam's going to be open next week. And I think in the Blackboard announcement, I said that we're going to take the exam on Wednesday. I know that date changed a little bit, but I wanted to make sure everyone had enough time with the review, and I didn't get the review out until yesterday. So I wanted to leave a full week because different people have different days when they can spend time working. Okay, so now we get into asking these percent questions. Sherry's taxable income fell into the 12% marginal bracket, right, which we found, right, fell in here. What actual percentage of Sherry's taxable income did she owe? All right, and again, to figure this out, what we want to do is take that question and see if we can translate that into a math equation. Okay, so what percent, I'll write as a variable x. I know percent of means multiply. Sherry's taxable income. Okay, so this is what percent. And then I want the taxable income. Well, the taxable income I have written down as $37,500. Okay. Did she owe? So another way to look at that is that what percent of the taxable income is equal to what she owed, right? And that's $2,105. Okay. So if you translate it like that, what it does is it gets the correct numbers in the correct spot, right? So I can see taxable income is written there, so that's what I'm going to fill in as the taxable income, okay? And it's what percent of the taxable income, so my variable is being multiplied by the taxable income. So if I want to get X by itself, I have to divide by 37,500. Okay, and doing it this way, I can be sure that I'm dividing the correct direction. I'm not dividing, with the numbers flipped or something like that. It's very easy to make mistakes like that where you either have the wrong number put in or you have them in the wrong order. Okay, so that's why I like to sort of directly translate the statement. Okay, so when I divide this, I get 0.0561 repeating. If I turn this into a percentage, I will get 5.613%. Okay, and it says just round to one decimal, so I could just write 5.6%. Okay, the next question is almost identical. It says, what percent of her gross household income did she owe in taxes? So for this one, I'm going to go about the same process, but instead of using the taxable income, I'm going to use the gross household income. So again, I have this what percent, then I have my gross income. We gotta scroll up a little bit and remember, oh, that's 63,000. Okay, and again, it's equal to the amount we paid in taxes, or the tax owed, 2105. Okay, so again, I can see, all right, I'm going to take 2105 and divide by the 63,000 to get my percentage. Okay, and if you're ever not sure about rounding, just use more decimal places. And that's fine too. All right, it won't mark you wrong if you use too many decimal places. All right, any questions over this? All right, let's go ahead and start looking at some of the practice exam. The first few questions are going to be, from going back in time, computing with percents and stuff like that. And this is, again, probably helpful to review when you get to those questions in that section 1.9 when it starts asking about these, what percent of tax did people pay? Okay, and that was one of the points of reviewing this at the beginning. Okay, so what I like to do with these, as I said when we were just doing that homework problem, is I like to translate each word directly into a math symbol. Okay, so when I see what, I write a variable. Okay, is means equals. Okay, 20% I change to a decimal. A percent of means multiply. Okay, and then 16. Right? And once you have an equation written down, then it's typically very simple, right? Because you just say, oh, okay, I'm taking 0.2 times 16. That's my answer. Okay. Right. So I get 3.2. No problem. Okay. The next one, 15, means equals what percent, so I put my variable, percent of means multiply, and 25. So here I can see, okay, I need to do a step of work. I can't just multiply directly, I have to divide. Okay, so 15 divided by 25 gives me 0.6. All right, and it says what percent, so I want to write my answer as a percentage. Okay, so 0.6 turns into 60%. Okay, 8 means equals, 30% I write as a decimal, percent of is multiply, and what is my variable? So 8 is 30% of what? And I can see, oh, okay, in order to get my variable by itself here, I have to divide. Okay, so we take 8 divided by 0.3, and I get a repeating decimal, right? So you could write 26.6 repeating, or you could, write it out a few of the sixes and then do the rounding like 0.667 or something like that. Okay, and those are acceptable. All right. The next one, what percent? So that's my x. Percent of means multiply. 130 means equals 182. Okay. So now I'm going to divide both sides by 130 to get my variable by itself. Okay, so we get 1.4. It said what percent, so I want to convert that to a percentage. So I move the decimal twice, so that's 140%. Okay. One of the things I really want to encourage you to do is to, when you're working out problems, especially when you're doing practice problems, is to actually write stuff out. Okay. Don't have a blank page in front of you and all your work is on the calculator and you go through and check stuff. That's not really a good habit of mind, right? It doesn't produce good study results, and it makes you a lot more prone to making simple mistakes. One of the most frustrating things that I run into frequently is somebody who knows what they're doing, but got a poor test score because they made little mistakes. They maybe divided the wrong way, 130 divided by 182, or stuff like that, or, didn't convert to a percentage, or move the decimal place too many places or too few. Things like that. You can't just tell yourself don't make a mistake, but what you can do is you can have habits that reduce the likelihood that you make a mistake. Okay, and writing stuff out helps with that. Okay, so the next couple are percentage increase and decrease. Okay, so what is the percentage increase from 40 to 50? And the way that I like to go through these is to break it into multi-steps. Yeah, when you meet with me after a test, you should definitely bring the scratch paper that you used. And I'll make that a lot more clear. When I post the test, I'll post up instructions about it so that you can you know exactly what's going on. But yeah, you should definitely have your scratch paper handy. Okay. what is the percentage increase from 40%, or sorry, from not 40%, just from 40 to 50? So first we find the amount of increase. Okay, and it went up by 10. And now we want to say, well, what percent of 40, right? Because we're increasing from 40, what percent of 40 is 10? Okay. And if I write the question that way, and hopefully that makes sense that I asked that, right? Because I want to know the percentage increase. Well, if the increase is 10, then I'm really asking what percentage of 40 is 10. Now I can just translate that into symbols like we did above, right? So what percent is X? Percent of 40 is means equals, and then 10. So I divide to get 25%. Okay. All right, the next one, what number is 35% more than 80? So again, I'm going to break this into two steps rather than the one step that we were doing for questions 1 through 4. I'm first going to figure out what is 35% of 80. Okay. So X equals 0.35 times 80. Okay, and I get 28. All right, now I'm going to look at the actual question that I was asked, and that is, what number is 35% more than 80? Okay, so 35% of 80 is 28. So what number is 28 more than 80? Okay, so X equals 28 more than means add. And when I add these, I get 108. All right. These are not the fastest way to do these problems, okay? What I'm trying to show you is a very thoughtful way to do the problem so that you don't make a mistake. And on a test, right, you know, saving 5 minutes is probably not as good as not making little mistakes. So, you know, if you had 100 problems like this to do, you would want to find a shortcut. But on a test where you only have a few problems to do and you want to make sure you get them right, you know, it's a good idea to practice doing things thoughtfully and carefully. All right. So this one doesn't feel like it's in the right order from what we did with the topics, because sales tax we did much later on. Okay. However, when we talk about like percents and percent increase and decrease, that kind of fits in with this section 1 stuff. So maybe being next to each other on the review isn't so bad. Okay. But the review doesn't have to be in order anyway, and it's not, because the test isn't going to be in order. Okay, it's not like, oh, this is from section 1, this is from section 2. It's just everything's all over the place. All right, so let's go ahead and look at this. So the desk is $125. It's 25% off. So first I want to find 25% of 125. Right, is what? So I have a percent of is multiply, 125. So that's $31.25. Okay, so that's the amount of discount. So then that answers this question, but for moving on, what I want to do is I want to write out the discounted price. right? Discounted price, or the new price of the desk, is going to be the $125 minus the amount of discount. So I get $93.75. Okay, so when we're charged tax on the discounted price, not the list price that we're not actually paying. Okay, so we want to take the tax is 7.25% of $93.75. So I change my percent to a decimal. Percent of means multiply. So we take 0.0725 times 93.75, and we get $6. And well, I'll write out the decimal that I get on my calculator. Okay. When we do things with money, it's typically, you're going to be safe if you just always round to the nearest cent. Okay. So we'll say $6.80. Okay. So then how much do you pay for the desk? We're going to take the discounted price and add in the tax. So we take $93.75 and we add $6.80. Okay, so we get $100.55. Okay, and the order here is kind of forced because of the order of the questions, but it does matter. You take the discount first and then you apply the tax to that. If you did the tax first and then the discount, you could still get the right ending price as long as you're discounting the tax as well. But you end up paying a bigger you end up paying too much tax. So the order matters a little bit there. Okay. Some more percent increase and decrease. A man started at a fitness center weighing 250 pounds. After 6 months, he weighed 180 pounds. What was his percent body weight loss? Okay. So just like we did up here with the percentage increase and decrease, okay, what we want to do is first find the amount of increase or decrease. Okay. So the amount of weight loss is the difference, 250 minus 180. That gives us 70. And now we want to find what percent of his 250 pounds is that 70-pound loss. Okay. So then I turn that into a math equation. What percent is X? Percent of means multiply. Is means equals. And then I have my 70. Okay, so then we divide to get X by itself. 70 divided by 250 gives me 0.28, which is 28%. Okay, suppose you buy a stock for $100 on Tuesday. On Wednesday, it's up 10%. On Thursday, it's down 10%. How much is it worth now on Thursday? Okay, and then we have a separate second question. We'll deal with that after we answer the first. Okay, so on Tuesday, it's $100. Okay, on Wednesday, okay, it says it went up by 10%. So 10% of 100, That's 0.10 times 100, which is $10. So it's up $10 means that we have $100 plus $10. Okay, so on Wednesday, the stock is worth $110. Okay, on Thursday, it went down 10%. It doesn't go down 10% of its value on Tuesday. When it goes down a percentage of what it is currently at. Okay, so we want 10% of what it's currently at, and on Wednesday it's worth $110. Okay, so I'm going to take 10% of 110, which is 11. So down $11 from 110 is 110 minus 11, or 99. So how much is it worth now on Thursday? It's worth $99. Okay. So one of the things that I want you to notice there is that if you go up by 10% and then down by 10%, they don't just cancel each other out. You don't land up in the same spot, because after we go up, when we're changing by a percentage, we're changing to, it's a percentage of a different amount. So it doesn't, it doesn't land us back where we started. Okay, so let's answer the second question. And rather than try and think through it, what we can do is just actually work it out. What if we lost 10% first and then gained 10%? Okay, why don't we just write that out and see if it makes a difference? And then we'll talk about why the answer is what it is. Okay, but I think the way to be sure is to actually write it out. Okay, so if we start at $100, okay, and we go down 10%, okay, 10% of $100 is $10, okay, so we go down to, I should do the subtraction, it's $90, okay, and now we go up 10% of 90, 10% of 90 is 0.10 times 90, which is 9. Okay, so if I go 90 and add 9, I get 99. Okay, so it does not make a difference. Right. Okay, it's enough to just say that there is no difference. What I'm going to do is I can maybe give you a mathematical explanation for why is there no difference. Okay, and in order to do that, what we have to do is look at maybe a fancier way of computing stuff. I did things very deliberately where I found the percentage first and then I added it on. Okay, but what we did here is we took 10% of my starting amount, and then what I'm doing is I'm taking my starting amount and adding on that 10%. So if I have my starting amount or principal P, I have P plus 10% of P. Okay, which is like, if I factor out the P, that's like P times 1 plus 0.10, or 1.1 times P. Okay, So adding on 10% is like multiplying by 1.1. Okay. If I go down by 10%, okay, what I'm doing is I'm taking my starting amount and I'm subtracting 10% of my starting amount. Okay. So again, if I factor out the p, I have 1 minus 0.10, or it's like multiplying by 0.90. If I take away 10%, it's like leaving me with 90%. So I have 90% times p. Okay. So if what I go from Tuesdays to Wednesday is multiplying by 1.1, and then from Wednesday to Thursday is multiplying by 0.9, multiplying doesn't matter what order you multiply in, you get the same thing. So if I multiply by 0.9 first and then multiply by 1.1, okay, or multiply by 1.1 first and then multiply by 0.9, it's all the same. And that's why there's no difference. Okay. I think that explanation is a bit more difficult to articulate. So I think it's a lot better just to work it out. And then you can see no difference. And that's very clear. Okay, let's do one last problem today. Sally loaned her brother $5,000, saying she would charge him 3.5% simple interest on the loan. This is key. If the problem says simple interest, you're going to use the simple interest formula. If the problem doesn't say simple interest, you don't want to use the simple interest formula. So our simple interest formula is I equals PRT. Okay. So I need to identify the pieces. Okay. She loaned her brother $5,000, so P is 5,000. Okay. She's charging him 3.5%, so our interest rate R is 0.035. And I have to read on in the problem, how much did he pay her back when he settled his debt 2 years later? So how much did he pay her back? That's finding the amount A. Okay, so the interest is not the answer to my question. The amount A is the answer to the question. Okay, and it's 2 years later, so T is 2. So I can use my simple interest formula to compute the interest. So 5,000 times 0.035 times 2. So I get $350. Okay. The amount that we're going to pay back, though, is the original 5,000 plus interest. So our original 5,000 plus the $350 in interest gives us $5,350. Okay. I think the more important part of this question is making sure that you identify how to set it up. Okay. If it says simple interest, use the simple interest formula. And if it doesn't say simple interest, you don't want to use the simple interest formula. Okay. And that'll make a difference when we go on later and, you start talking about, okay, we have a couple of taxes, but when we start talking about, compounded, right? So things compounds daily, okay, or contributing monthly, and it gets compounded monthly, things like that. We're going to use the different either compound interest formula or savings formula or the loan formula, okay? And those are the ones that are built into the finance app on the calculator. When it says simple interest, you have to just use the formula, okay? All right, any questions about that? All right, well then, I think that we're